this problem, we want to work with the demand curve. You're asked to sketch the demand curve and then determine the quantity demanded when the unit price is set at $6. We're going to give our answer to the nearest full unit. The key here is to keep in mind that as you're working through the problem, when we get to the end, you want to remember that this is given in units of 1,000. So when it says the nearest full unit, we need to be careful about what that means when we are rounding. So when we go to solve for the price, we know that the price would be 6, and we're going to solve for x. We're going to square both sides. I'm going to solve this equation by getting x squared by itself and the numbers on the other side. So I'm going to go ahead and bring the x squared to the left side and bring 36 to the right side. Remember, when things change sides, we switch signs. So 49 minus 36 will give us 13. Take the square root of both sides. Remember, technically we would do plus and minus the square root of 13, but since we can't have a negative quantity, we're going to just keep the positive. Now the square root of 13, we don't know that off the top of our heads, but we can put that into our calculator. And the calculator says 3.605 and so on. Now this represents units in 1,000. So we're not going to round yet because this is not to the nearest full unit. This represents 3.6055 thousand units. So first we're going to write out what this means in terms of the actual quantity. So 3.6.055, that represents really 3,605 units, 0.5, and so on if you look in our calculator. So first of all, we're going to say this is the actual units that's represented by x equals 3.60555 and so on. So when we're rounding to the nearest unit, we're going to have to be careful here. This is actually the units, and we're going to round to the nearest full unit, so that means that brings that up to 3,606. So we want to be careful when we're rounding. First convert back to the actual quantity, and then we'll round to the nearest full unit.